In this video, we're going to be talking about limits, and this is just an introduction to limits. Now, strangely enough, sometimes when we're trying to do something, we can't actually work it out directly, but we can see what it should be as we get closer and closer. So, let's look at an example to see what I mean. Let's say that we had x squared minus 1 on the top and x minus 1 on the bottom. Okay, so let's say we wanted to work this out for x equals 1. Okay, so what we're going to do then is going to plug in 1 wherever there is an x. So we're going to get 1 squared minus 1 over 1 minus 1. And that is equal to 1 squared is equal to 1 minus 1 over 1 minus 1. And you should know pretty basically that's going to give us 0 over 0. Now, this is a problem, okay? We don't actually know what this value is going to be. It's indeterminate. So we need another way of trying to answer this question. So instead of trying to work out for x equals 1, why not try answering for x as it approaches 1, okay? So for example, we could instead put in stuff like 0.5 into the equation, or that looks like more like a 6, we could put that into here, or we could put in 0.9, or we could put in 0.99, we could put 0.9999 into there. You know, as it approaches 1, what values are we going to get out? Okay, so let's give this a go. And let's just get rid of this blue part as well as I can. So we got this here, x squared minus 1 over x minus 1. So let's say we start with x and then we're going to get our value out over here, okay? So if we put in 0.5 into our calculator and put x squared, so 0.5 squared minus 1 over 0.5 minus 1, we're going to get 1.50000 out in our calculator. Okay, how about if we did 0.99? What are we going to get? Well, that actually gives us 1.99 and so on. And then we could keep going, you know, 0.9999, for example, it's just going to give us 1.999, etc. So as you can see, as we get closer to 1 with our x, we're getting closer to 2 in our output. So, you know, we got an interesting situation here. When x equals 1, we didn't know what the answer was, because when x equals 1, that gave us 0 over 0, which is indeterminate, okay? But what we can see that if it is 1 in here, that is actually going to be 2, okay? So we want to give the answer 2 here, but we just can't, okay? So instead, mathematically, what we can say is going on is using the concept of a limit, okay? So what we could say is the following. So let's just get rid of this. We could say that the limit of this here, x squared minus 1 over x minus 1, as x approaches 1, that is 2, okay? So the limit of this as x approaches 1, so as x gets closer to this number, that is 2, as we saw from the table that we had here a minute ago. And if you want to be extra clever, we can write this down mathematically as lim. So obviously lim stands for limit, and we're going to put x approaches 1. So that goes underneath it. So the limit as x approaches 1 of the sum x squared minus 1 over x minus 1, and then that is 2. So that is equal to 2. And that's how we could express the same thing mathematically. So this is just a special way of saying ignoring what happens when we get there, but as we get closer and closer, the answer gets closer and closer to 2. Now, we could write this down or draw this as a graph as follows. So, let's try it. We would draw our y-axis, we got our x-axis, and we're going to put like 1, 2, 3, 4, 1, 2, 3, 4. Very quick graph here. And what we've essentially got is this sort of a process where it's a straight line like such. And this isn't a very good one, but it's very quick. But at this point here where we've got x equals 1, okay, we can see that as we approach 1, we got a little gap here, okay? And essentially, we don't know what this value is, but we do know that as x approaches 1, the value is going to be probably 2. It's 2, okay? But we don't actually know that conclusively, because we knew that when we put x equals 1 into, x squared minus 1 over x minus 1, we got an indeterminate answer. But we can say that as we approach 1, the limit is 2, which is why we got a little hole on the graph itself. Now, we've only checked one side, and it's important that we also check to make sure that this is the same from both directions. In other words, we want to see whether, so we approached x from this way, we started at 0.5, looked at 0.9, and we got to 1, but we also want to look at it from this way as well. So we start with like 1.5, go to 1.01, etc. Okay, so let's now try this from the other side and see whether or not we also approach 2. So this time we're going to have x, and then we got whatever our answer is going to be. So let's say we put in 1.5 as I suggested. Okay, if you put 1.5 into that calculation, you're going to get 2.5 back out. Now how about we try 1.01? If we put 1.01 in, we're going to get 2.01, etc. And if we went even closer to 1.00001, so a very small number, or very, very close to 1, I should say, we're going to get 2.00001, etc. Okay, so again, you can see that we're also heading for 2, so we can see that's okay, and this seems to be the correct limit. We also have this concept of infinity, which is a very special idea indeed. So we can't actually reach infinity, but we can still try to work out the value of functions that have infinity in them. So what if I asked, for instance, the following question? Let's say, what is the value of 1 over infinity? Okay, what is the value? Well, unfortunately, we don't actually know, okay? And the simple reason that we don't know, and the simple reason is that infinity is just not a number, it's an idea. So 1 over infinity is the same as saying, I don't know, 1 over chicken, okay? It's just a thing, it's an idea, okay? So maybe we could say that 1 over infinity is equal to 0, but that is a problem too, because if we divide 1 into infinite pieces and they end up being 0 each, then what actually happened to 1? So in fact, 1 over infinity is actually, again, undefined. Okay? But like with our example earlier, we can approach it. We can approach infinity. And this is another example where limits are useful. So instead of trying to work out for infinity, because we can't get a simple answer, we can try larger and larger values of x. So what I mean is, we can put larger and larger values of x where the infinity sign is. So let's try that now. Let's say we have a column on the left, which is going to be our values of x that we're going to put into the calculator, and we're going to have the value of 1 over x, okay? So of course, if I just put 1 into the calculator, where x is 1 over 1, 1 divided by 1 gives us 1, okay? That's not particularly close to infinity, but let's say we put 10 into the calculator, we're going to get 0.1. If we put in 10,000, so a substantially larger number, we're going to get 0.0001. And we can see then that as x is getting larger, 1 over x is getting closer and closer towards 0. So 1 over x tends towards 0, okay? It's sort of going towards that direction. Now, we are faced with an interesting situation here, okay? We can't say what happens when x gets to infinity because that's undefined, but we can say, and we can see, that 1 over x is moving towards 0, okay? So, again, we want to give this answer 0, but we can't, so we're going to have to express this mathematically. So what can we say to express this mathematically? We can say that the limit of 1 over x as x approaches infinity is 0. So mathematically, we do it like this. We write the limit of x as it approaches infinity, okay, of 1 over x is equal to 0, okay? So in other words, as x approaches infinity, then 1 over x approaches 0. So this is just a mathematical way of saying we're not talking about when x equals infinity, but we know that as x gets bigger, the answer gets closer to 0. Okay, that is the end of this introductory video on limits. But if you have any questions about this at all, then please leave a comment below and I'll get straight back to you. If you enjoyed the video, then please leave a thumbs up and subscribe to my channel. Thank you very much for watching.